Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Wemets. And without any further ado, let's look at this question that we are given here. Okay, so we have question 5 on basic trigonometry. It says 4 tan alpha plus 5 is equals to 0, and alpha is an element of 0 degrees all the way to 180 degrees. Now they're saying evaluate without using a calculator root 41 cos alpha minus 4 sine negative 150 degrees cos 180 degrees. Right, so now to solve that, we know that the first thing that we have to do is find our tan alpha here in the form of a fraction. So that we have 4 tan alpha plus 5 is equals to 0. And then solving this is 4 tan alpha is equals to negative 5. We divide both sides by 4. Then our tan alpha is equals to negative 5 over 4. But then look at this. We are given that alpha should be an element of 0 degrees to 180 degrees. So that is inclusive of the first and the second quadrant. So the first quadrant is from 0 to 90 second, 90 to 180 degrees. Now, where is tan negative between the first and the second quadrant? We know that it will obviously be in the second quadrant, meant to say, because in the first quadrant, we say all trig ratios are positive. So that means we have to draw the diagram here, or the right angle triangle in the second quadrant. So this is opposite over adjacent according to SOHCAHTOA. So if we have our alpha here, our opposite side is positive 5 and our adjacent side is negative 4, right? Based on our Cartesian plane. Now to calculate the value for r there, we have x squared plus y squared, right? So we are calculating the hypotenuse side. So this is negative 4 squared and then plus 5 squared. This will give us 41. But then if we have to square both sides like that, then our r is root 41, right? So let's put our root 41 there. So now we have filled in the diagram. That means we are ready to calculate this one. So to calculate, we have root 41 and then cos alpha minus 4 sine negative 150 degrees and then cos 180 degrees. So this here cos alpha gives us what? Adjacent over hypotenuse. So this is our adjacent negative 4 and our hypotenuse is root 41, right? And then here we have minus 4, but then we know, let's check this. We know that sine of a negative angle is negative. So when the negative multiplies with that negative outside here, this will become positive. So this will be positive 4 sine. Let's just reduce this 180 here in this 150 here, meant to say in terms of our reduction formulae. So this will be 180 degrees minus 30 degrees. And then we have our cos 180 degrees, which we know this is a value of negative 1. So let's just write it like that. Now this and that will cancel out. We are left with negative 4. And then if we say positive 4 multiplied by negative 1, we will have negative 4 here as well. But then sine 180 minus 30 represents the second quadrant. How is sine in the second quadrant? It is positive. So this needs to be sine 30 degrees like that. So this is negative 4 minus 4, but then sine 30, we know that half. So what is 4 multiplied by half? The half of 4 is 2. So we have negative 2. And then now, having to say negative 4 minus 2, this will give us negative 6. So this is the numerical value of all this, right? So that's what we were required to find, the numerical value of all this expression here. And then that's negative 6. So that's how you were supposed to tackle that for a total of 5 marks, right? Then let's proceed. So we have 5.2.1. And then it says simplify without the use of a calculator. We are given this. So what we need to do here is just simply use the karate method, which we simply just take this, multiply by that, take this, multiply by that, and then we multiply the denominators. So using that, we will have cos 99 degrees and then sine 33 degrees minus sine 99 degrees multiplied by cos 33 degrees. Then having to multiply the denominators, this will be cos 33 degrees and then sine 33 degrees. Right. Now, having to look at the numerator here, we can see that it resembles a compound angle that we know. So if we can just visit the compound angles here and then try to identify which one is similar to that. Now look at this. We have cos 99 sine 33, sine 99 cos 33. This kind of resembles this one. But then the only problem here is that they started with cos instead of sine. But then this is not a trace match because you can just flip the position for this one. So you can just say sine 33 and then cos 99. And then also here, rearrange cos 33, sine 99. So it looks exactly like this one if you do that. Then, okay, so let's do that. This will be sine 33 and then cos 99 minus cos 33 sine 99. So always note that you must not tamper with the positions of the angles here. So if you are starting with 33, even this one needs to start with 33. If you are ending with 99, even this one needs to be 99. Then over, we have this one. Let's arrange this one as sine 33 and then cos 33 so that it looks a bit similar to what we have as the double angle. Then let's look at this. This will now become sine 33 degrees minus 99 degrees over sine 33, and then we have cos 33. Right. Now, 33 minus 99, this will give us a sine negative 66 over sine 33, and then here we have cos 33. Right. If you can look at this, this 66 in terms of the 33s that we have down here, we can see that 66 is actually a double angle. Right. So that means we can break this down to a negative 2 sine 33 degrees and then cos 33 degrees. From the double angle, if we have sine 2 theta, then we know it becomes 2 sine theta and then cos theta. So we just broke it down based on this double angle here. Now we have down here sine 33 and then cos 33. Now looking at this, you can see this divides this and that divides. So we are left with negative 2. So that should become your solution, right? So that's all you were required to do there for how many marks? Let's check. So that was for 6 marks. Okay. 5.2.2, we are given cos 140 degrees minus sine 90 degrees minus theta. This is over sine 130 degrees plus cos of a negative angle. So we know that we should reduce this one in terms of reduction formulae. This will be cos 180 degrees minus 40 degrees. And then the cofunction for this one, it changes to cos theta over sine 130. This will be sine 180 degrees minus 50 degrees. And then this is positive cos theta because cos of a negative angle remains positive. Right. Now look at this. This will give us a cos. How is cos in the second quadrant? It's negative. So it's supposed to give us negative cos 40 degrees. So this is negative cos 40 degrees and then minus cos theta over this here. How is sine in the second quadrant? It's positive. So it will give us sine 50 degrees then plus cos theta. Now here we have a negative. So that means we can factor out the negative and then this will be cos 40 degrees, and then plus cos theta. So you understand why it becomes positive, because negative times positive will give you that negative over. Now this is sine 50 here. We know that always with these questions, we are looking forward to just having something from the numerator cancel out with something in the denominator. So how can we try to be creative with this sine 50 degrees here? Note that we have cofunctions. And mainly what we know with cofunctions is that if we have cos 10, for example, then we know that this is equals to sine 80 degrees, because 10 and 80 are complementary angles meant to say, so they add up to 90 degrees. So the same with this one, we have sine 50 degrees. We know that our sine 50 degrees will be equivalent to cos 40 degrees. If you say 50 and 40, these are complementary angles because they add up to 90 degrees. So that means, in other words, I can change my sine 50 here to cos 40 degrees. So this will now be cos 40 degrees plus cos theta. Now, what do you see in the numerator and denominator? We can see that now this is the same thing. So we can just divide out that, and then we are left with -1. So that's how you were supposed to tackle that one. Okay. Let's proceed. Okay, so we have 5.3. It says prove the identity. We are given 2 sine squared x over 2 tan x minus sine 2x, right? So how do we approach this one here? Okay, so the first thing that you want to do is write this in a manner that will be friendly for calculations, right? So we can say 2 sine squared x divided by 2. So breaking down the tan x, this would be 2 sine x over cos x. Remember, I said divide because over means divide. Then minus, if I break down this double angle, this is 2 sine x cos x, and then I can just say over 1 so that it also becomes a fraction. Then this will be 2 sine squared x. Remember, I'm proving from the left-hand side. So I'm trying to make my left-hand side to be equal to the right-hand side here. So this is divided by, if I use the Karate method on this one, this is 2 sine x, and then the cos x will multiply over there. So this is 2 sine x, and then cos squared x. Then if I multiply the denominators here, I have cos x as my LCM, right? So this will become 2 sine squared x divided by, if you can have a look at this, the 2 sine x now becomes a common factor. So let me factor out 2 sine x here, and then this will be, so let me use a square bracket so that it doesn't get confusing. So this is 1 minus cos squared x, like that, and then over cos x. Okay, but then we know this from grade 11. From grade 11, we know that 1 minus cos squared x is equals to sine squared x. So let's just change this one here. So this is 2 sine squared x divided by 2 sine x, and then if sine squared x, so this is sine squared x, meant to say, then over cos x, like that. Okay, now using our tips and times here, we can say this is now 2 sine squared x multiplied by, we know if we change the divide sign to multiply, then the denominator becomes numerator and numerator becomes denominator. So this will be cos x over 2 sine squared x multiplied by sine x. So I just simply multiplied this one. Now, look at this. This and that will now divide out. So in the numerator here, I'm left with cos x. In the denominator here, I'm left with this sine x. Look at the magic. So I can then conclude the left-hand side is equals to the right-hand side. In that way, I have proven my identity. Okay, so let's proceed to 5.4, the general solution. We are given a 8 sine theta cos theta is equals to -2 root 3. Right. Now, what I want to do with this one is I can see that if I can just manipulate here, I can end up having a double angle for sine. Remember, with general solutions, I want to work with a single trigonometric ratio. So I have two here. I have sine theta and I have cos theta, which makes it impossible for me to get my general solution. So, but then if I can just write this as 4, and then in bracket 2 sine theta, and then cos theta like that is equals to -2 root 3. I can now see that what I have inside the bracket here is a double angle. So let me divide both sides by 4. And then this double angle here will be sine 2 theta. And then here I have -2 root 3 over 4. Now, in calculating your reference angle, note that you do not have to substitute this negative. The negative is only telling you which quadrant you need to find your general solutions from. Right. So to calculate my reference angle, I will just leave this 2 theta here and then go sine, inverse of sine, and then 2 root 3 over 4. Now, punching this into your calculator, you'll have 2 theta is equals to 60 degrees. Another mistake that you guys make is to want to calculate for theta here. At this point, you are solving for general solution, not for theta. So you need to pause right there and just name this the reference angle, right? So you do not solve anything there. As soon as you get the angle, just say reference angle. Now, looking at this, you had a negative, so that means you must find your general solutions from the quadrants where sine is negative, right? So, using your cast diagram, we know that sine is positive in the second quadrant and the first quadrant. That means it is negative in the third and the fourth. So let's find the solutions in the third quadrant. So to find the solutions in the third quadrant, we know that in the third quadrant, our reduction formulae is 180 plus theta plus theta. So this will be 2 theta is equals to 180 degrees plus our reference angle of 60 degrees, then plus k 360 degrees. Note that this 2 theta here is still the same, right? So that's when I can start dividing it here. After I've got the solution for this one, this is 240 degrees plus k 360. Now I can just divide throughout by 2, including here, right? So the 2 here reduces the period. So this is theta, and then this will give us 120 degrees plus k 180 degrees. So as a result of this 2 theta here, now my period is 180 degrees. Now let's find the general solutions to the fourth quadrant. So this will be 2 theta, and the reduction formulae in the fourth quadrant is 360 minus theta, right? So this will be 360 degrees plus minus, meant to say. So the reduction formula in the fourth quadrant is 360 minus theta. So that's 360 degrees minus 60 degrees, and then plus k 360 degrees, right? So this will be 2 theta is equals to 300 degrees, and then plus k 360 degrees, right? Then having to divide throughout by 2, then I have theta is equals to 150 degrees plus k 180 degrees, where k is an element of integers, right? So that's how you were supposed to solve that one there, right? So you have found your general solution, and all that was for 29 marks. So this was a very lucrative deal of marks, right? So that's how you were supposed to go about answering that question. Please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.